Good morning, Puneet. This is Srini.
Hi Srini, very good morning. So Jignesh is traveling today. So
Is traveling? Okay.
yeah, so he won't be able to attend today's session. So
Okay.
let's
Fine.
let's continue. I've shared my screen.
Okay.
So, any question to begin with regarding yesterday's class or anything?
No. So looks clear, but I didn't spend a lot of time after that. I got busy. But yeah, everything was clear. No questions so far.
Okay. So today we will be covering these three things. One is subsetting in R. Second, how to read from external sources, specifically to
Okay.
CSV file. We'll see, and
Okay.
post that we will do exploratory data analysis, uh, missing value imputation, outlier treatment, and we'll use our graphical capabilities to understand all those things. And
Okay.
then if time permits, then we'll try to cover random variable concept and normal distribution.
Okay.
So let's start with subsetting. So I will tell you subsetting in vector and in data frame, because in these two data types, so just to revise you, uh, so there are primarily four data types in R, which we discussed yesterday. So vector,
Right.
matrix, data frame, and list. So we'll be studying in depth subsetting for vector and data frame, and how to do subsetting, what is the advantage, why we need that, so all that stuff. And we'll also do hands-on session to understand each and everything. So
Okay.
yeah, so this is a vector uh, from 1, 5, 10, and 13. And in subsetting, basically what we do, we write the location within the square brackets, and we pull
Hmm.
that corresponding data for that location from the data type, so vector in this case. So a of 2, so syntax is square bracket open, then the location, and then square bracket close, and it will give me the value for that location. Now if we want to fetch multiple records from multiple locations, then we have to pass a vector within a vector. So let me show you that. So open RStudio, we'll be doing that thing in RStudio only. Okay, so I have defined one vector. Okay, so I have pulled a second location value from this vector.
Mm-hmm.
Or if you want, so here in this case the vector is very simple, so let me change this vector to some different values.
Yeah, makes sense.
So second location, and then I have to pass this command also. Yeah, now it is giving me 20. Similarly for the third location, it is giving me 100. So fairly simple.
Yeah, it's not clear.
Yeah. So now
So
if
in the example, you gave like a vector inside the A, right? What is
correct,
A? A is a variable.
is a data type, vector data type.
No, no, A is a data. You're just naming that, right? Um, you're
Yeah.
just
So it's a
giving a
vector
name
object. It's a
to
vector object. Correct.
okay object name.
Yeah.
Okay.
So now if I have to pull multiple values from this vector,
Mm-hmm.
so there are a couple of ways. So one is, so it depends whether I need continuous values or values separated from each other. So for
Right.
example, Yeah, so it's very straightforward. So I wanted second and third value.
Mm-hmm.
So it has given me uh, corresponding values from the second and third location, which you can see on my console. And there is one more way to do subsetting by writing colon sign or defining another vector within this vector, but it has to be in the square brackets.
Right.
Since I want continuous
Okay.
values, so I can pass it through colon. So it
Mm.
has given me 20, 110. Now, uh, I want to fetch the maximum value out of this vector. So,
Mm-hmm.
uh, so in the vector CS in my slide, so as we can see, 9 is the maximum value. So how to get that maximum value from any vector? So for that there is a which dot max function in R. So what it
Mm-hmm.
does, basically which dot max of any vector, it gives the first occurrence of the maximum value. Okay.
Okay.
So in this case, the first occurrence is third location, right?
Yep.
And if I'll do simply which dot max,
Yes.
yeah. So there are two things. So first, if
Mm.
I simply type this command, which I have highlighted, which dot max CS. So CS is my vector containing 1, 2, 3, 4, 5, 9 values, and I have defined it as a vector, right? Now,
Yeah.
I want to know the location of the maximum value. So which dot max will always give me the location, right?
Location, not the value.
No, yeah.
Okay.
So it will give me the location. So when I type which dot max of this vector,
Mm-hmm.
so it has given me the value of 3, which is the third location of the first maximum, occurrence of first maximum. So here we have 3 maximum values, 9 in the third location and in the 8th and 9th, correct? So maximum value
Mm-hmm.
is getting repeated number of times or multiple times. But since it has
Mm-hmm.
found the maximum value at the third location or the first location in this vector, so that's why it is giving the result as 3. So if I change,
Okay. There. Yeah.
so let's say if I,
I got it.
okay, now let me do this. Again,
But do you know how many times the maximum value occurred? Do you have another function to find out how many times it occurred?
how many times within this vector, right?
Yeah.
I have to see this. I don't know. I don't
Okay.
remember currently.
That's fine. Yeah.
So when I change this and I push that 9, at the later stage, then it is giving me 6 as the location, right?
Okay. Can you change the one of the 9s to 10 last 9 to 10 and then run it?
Last value?
So you have to do Control R. Yeah.
Correct.
Last value to 10.
Correct.
Yeah. Now run it. And then it should be done, right? So
Yeah. So first so let's not confuse. I have actually written one command here. Okay. So let's move step by step. Okay.
yeah.
Now I am
Yeah, I
doing,
got it. I'm trying to see. So maybe we have to run Control R when you change it.
yeah. So ninth is the location and
Yeah.
10 is the
And
value.
now we right. Oh yeah, yeah. Got it, got it.
Okay.
Yeah. Right. You're right. Yeah. Okay. Got clear. We can move on. Yeah.
Okay. Now let's understand subsetting in data frame. So I have defined a data frame with 5 columns, first having 3 values and all the remaining are constant. So there will be 3 rows. Right, so it would be like this. The first column will have 3 different values and the remaining are the same, which I have just passed, 2, 3, 4, 5. Now, how to do subsetting in data frame? So it's again square bracket open, and let's say I want the column in the value in second row and third column. So simply 2, 3 within the square brackets, which is 3, second row, third column. Okay.
Okay.
Got it?
Yeah, got it.
Okay.
I'm trying to figure out what is that one there.
Where?
It's just, yeah, in the result you're seeing 1 and then inside the square brackets.
Okay.
What is 1?
So, okay. So if I do class of this,
Okay. The numeric, right?
the numeric. So in R, it simply does the counting, right? So that 1 in square bracket does not hold any significance here. So it simply does the counting. So if I have, let's say, 100 values, okay, then it will do the counting of all those 100 values, and in multiple rows it will show. So okay, let me show you one thing. Okay, so I have created one vector with 1000 values.
Okay.
So see, again it is.
I see. Yeah.
So it basically helps in letting us know the count of that particular value in that particular row, right? So 10 means that 9.63 is the 10th value. Then 19 means 8.25 is the 10th value.
Got it.
Okay.
Okay.
So this R norm is a function which I'll be covering in today's class in the later part. So then we will understand this.
Okay. Yeah.
Okay. Then similarly, if I want, let's say, first column of this data frame, right? Then I will simply pass df and square bracket 1. Okay, so the first column, so we're fairly straightforward. Third column, so it will give me third. And if I want multiple columns, then I will write 1 colon 3. It will give me multiple columns.
So we can we print just one row?
Yeah. So
how do we do it?
yeah, so df first row and all the columns. So that's the way. 1 comma blank.
Oh, okay.
So 1 means first row, and after comma it's basically column argument after comma. So I've left it blank. This means all the columns.
Good. Okay.
Now I can also print multiple rows by writing either 1 colon 3 or 2 and comma like this. So it will give me 2 rows.
Oh, okay.
And I can also do like this by writing C. So 1 comma 3. So if I want first and third row and all the columns. So I cannot write 1 colon 3 because it will give me all the 3 rows. So here I have to use C vector. So I am highlighting that thing, what I have done, this one.
Right. 1 and 3.
1 and 3. So I have to pass a vector with C as a prefix. So it has given me first and third.
Okay.
And same holds true for columns. So for column, I will leave the first argument as a blank, comma, and let's say 2 colon 3. So I have second and third column. Got it?
So you need the comma there. What if we just type df and then 2 colon 3 without the comma?
Okay. Let's see. Yeah, so there will be one difference. Okay. So let's say if I have to choose only one column. Okay. Let's say I am selecting second column. So if I
Right.
write only 2 here without
Yeah.
comma, okay, simply 2.
Mm-hmm. Right.
So it is giving me V2, which is the second column. And
Mm-hmm.
if I write like this, comma 2, then also it is giving me the same thing. So notice these
That's
two.
the row, right?
No. Actually, are you able to view my screen clearly?
Yeah. Sure.
Oh, because I asked because so that if not, then I can change some settings.
No, df2, you have provided the second column, right? And df comma 2 is provided in a the column values in a kind of horizontal row.
Correct.
Okay.
So the
Okay.
difference is that if you will,
Yeah.
if you want second column and you
Yeah.
are simply writing that column number within the parenthesis, then it will always return the data frame. But if I write comma 2, then it will give me vector. So let's see this with the help of class. So that's the difference. So if I'll do class of df2 without comma, then see it is showing me data.frame. Okay. But if I'll
Data
do
frame.
class of df comma 2, then it will say numeric vector. So that's the difference. If you will provide
Oh.
commas, right, then it will
Yeah.
fetch that in the form of vector. But if no comma is there, then it will maintain the same data type, which is the original data type called data frame.
Okay. Okay. Yeah, got it.
Okay. Now there is one more thing, that there are three ways of fetching a column from a data frame. So let's again call that data frame df. Now if I want v4 column, okay, or the fourth column, so there are three ways of
Okay.
pulling the fourth column from this data frame. One is simply df dollar and the column name, which is v4. So this is one of the ways. Data frame dollar column name.
Okay.
Second is
So the
df.
class of that is data frame.
No, class of that is vector.
Okay. Try that again. Class. So vector values.
Numeric vector.
Numeric. Okay. Okay.
So it will be data frame only when you will pass it standalone. So the one which I showed you here,
Okay.
this example.
Yeah.
When you will pass
Oh,
that
got
value
it.
standalone, then only it will give you as a data frame. In all the remaining cases, it will give you as a vector.
Okay.
So we will always use this subsetting functionality to get the vectors in most of the cases.
Right. Right.
Now, so I was telling you the three ways of pulling any column from the vector from
Yeah.
the data frame. So one was simply writing data frame object dollar column name, which is v4 in this case. Another way is the one which I showed you, comma 4. Okay. So first argument is blank because I want all the rows,
Yeah.
and second is 4 because I want the fourth column. Now the third way, yeah.
Yeah. I'm trying to see, you're confused between the columns and the rows. Rows, how do you get the row? Column, 4 column is the row, fourth row, or 3 column is the third row?
So what do you
3
want?
comma?
Third row or fourth row?
Third row. We
You
don't
want?
have fourth row.
Oh, okay, correct. So you want third row, okay? So
Yeah.
3 comma blank. That's it.
Okay, that's the difference. The comma first for the columns, and then the comma next to the number is the rows.
Let me repeat. So first argument is row argument, and second argument is column argument.
Oh, got it. Okay, I see.
Okay. So
So
coming.
what if we do 2 comma 4?
Then it will give me just one value.
Okay. Okay.
Second row and fourth column. So which is 4. If you will see in the console, top side of the console.
Yeah. Okay.
Okay. My
Right.
original data set was there.
Yeah. Regular thing. Okay.
Yeah. So I was telling you the 3 ways of fetching any column. So
Yeah.
one was using dollar. This one.
Yeah.
Second, passing the second argument as 4, and the third one would be first argument blank because I only need the particular column, comma, then within quotes I will write the column name.
Oh, okay.
So this is the third way.
Okay.
So generally we use this one.
Okay.
The reason for using this is that you can pass the dynamic argument around this. So if I write I instead of 4, then I will be able to traverse this column movement within any for loop. So that would be very easy for me. So for
Yeah.
example, this comma I,
Yeah.
right, and where I
Yeah.
is a dynamic range. So
Mm-hmm.
so this format we use quite often, and the after this df $v4. This is the most commonly used way of calling the column. And the last one in quotes, I never use this thing, but just for the sake
Okay.
of knowledge, I was telling you.
Okay. Good.
Okay. Then let's go further deep down in subsetting. There are few more
Yeah.
concepts that are there.
Mm-hmm.
So let's say if I do df $v1
Mm-hmm.
equal to 2. Let's say I only pass this thing. So this is a conditional command. Okay. df
Okay.
$v1. So this means the first column, whenever it is equal to 2, or is this thing equal to 2? So we write double equal to signs whenever we are comparing in R.
Yeah. Yeah.
So, and what is my v1? So let me call the data frame.
V1 is the whole column, right? How can you just say equal to 2?
Yeah.
What are you saying? The number of values, or
No.
the actual value equals to 2?
So it will compare 2 with all the values of that particular column.
Oh, okay. I see.
That's why
So
it has.
if we have any, yeah.
Yeah, please go on.
Yeah, if we have any 2 inside that column, then it will. Oh, okay. It's that. Okay, it checks and then gives the values for each. Okay.
Yeah.
Each
So in
row
terms
in
of
that
true or
column.
false.
I see. Got it.
And if you remember, this is the third category of vectors which I showed yesterday. So one was numeric vector, second was character, and third was logical vector. So this is a logical vector,
Yeah.
false, true, false. So this is also a vector. So if I type here class,
Yeah.
so it is saying logical. So this is a logical vector.
Mm-hmm.
And logical
Got
vector will always contain two values, whether false or true. Okay.
Yeah. Okay.
And there is one more thing. If you do sum of any logical vector, okay, then it will,
Sum of a logical.
yeah,
Mm-hmm.
sum of a logical vector. So sum of a logical vector will always count the values containing true. So it is
Oh,
giving
I
me
see.
1.
Okay. So 1 true.
So sum of a logical vector is the count of number of truths in that vector.
Okay. So
But
let's change that to V2. Sum of df dollar V2 should get 3, right?
so what should be the answer according to you?
Yeah, just run that.
So it will
And
be
then
3.
we should get 3.
Yeah, it will be 3.
Just run. Okay. Okay, cool.
We got 3 because if you look
All
at
true.
the inherent logical vector which we passed,
Yeah.
yeah, so this vector contains all the values as true,
Right.
right? And
Okay.
okay. Now look at this thing which I am highlighting. So
Yeah.
what this is doing? Let's understand this. So it is referring to the same data frame which I am showing to you. So they both are same.
Okay. So you're asking the column 2, and then inside that column 1. Okay. So we're getting a logical of V1 if we have anything equals to 3, right, in column 1, and then if it is, we get a logical vector and then putting that inside that V2.
Correct, absolutely correct. So see,
Yeah.
you are absolutely correct that first it will give me the logical vector, and we know
Right.
that V1 contains 3 values, 1, 2 and 3. So if df dollar V1 equal to 3 means false, false, true, right?
Yeah. Mm-hmm.
Then false, false, true is my values, that is the outcome of this subsetting. Okay.
Right.
Now what I'm saying to df dollar V2, okay, let me show you. So what it will happen, that whenever you are passing a logical vector within a vector, then it will only fetch the value wherever that logical vector is true. So let me show you what I'm trying to say.
Okay.
Let's do step by step. First, so first I am passing, I am running df dollar v1 equal to 3. So it will be false,
Mm-hmm.
false, true. Okay.
Okay.
Now,
Yeah.
now when I will run this command, what it will do, that false, false, true, which was the output,
Yeah.
then from V2 it will only pick that location for which location the outcome is true. So it will be the third location. Okay.
Oh, I see. Okay. So
Okay.
what
So
is the outcome when you run it?
it will be 2.
Oh.
So this is the
So
data frame
you're
in the console.
saying,
So in the console you can see the V2 column. So V2 column has 2, 2 and 2. Okay. Now what I'm saying is that let's say first only run df dollar V2. So df dollar v2
I understand. Yeah.
will give me all
So
the.
it just found. Yeah. I got it. It just found the location of the true value and then providing the value of that.
Correct,
So,
correct.
so yeah, okay.
So, and this is a very, very important concept, and we will use it quite often.
Oh, okay.
We will be using logical vectors as a subset, and wherever that logical vector is having a value of true, I mean the location,
Right.
wherever the location is within the logical vector is true,
Mm-hmm.
my outcome will be the values of the v2 vector in this case against that true locations. Okay.
Right.
So let's see this with one more example. df dollar v1 v कहाँ लिख रहा हूँ here equal to 2. So I have changed a bit. Now I am saying
Yeah.
whenever df dollar v1 equal to 2, so its outcome will be false, true, false. Okay.
Yeah.
Now in false, true, false, it's the second location which is true. Okay. So
Mm-hmm.
from v3 column, it will only pull the value which is present in the second location of that vector.
Okay. Right.
And what is that location? I mean, what is that value? It is 3. And because here all the values are 3, so you'll get the 3 as output.
Okay.
So this is the original table. So
Yeah.
let me create one more column, then we will understand this. So cbind is a function to add one more column or multiple
Okay.
columns to the existing data frame. So
Okay.
let me
Good to know.
create one more vector data frame df1, and what I am saying is that cbind of df, and we can even keep the same name. There is not necessary to
Yeah. Okay.
rename to pull the different name, comma v6 equal to
Okay.
now let's see the df data frame. Okay, look at the sixth column.
Mm-hmm.
So I passed the vector 4 colon 6, which is 4 5 6. Okay, now
Yeah.
let's do the subsetting df. Now I want some value from the v1 vector. Okay, so I have written df dollar v1. Now I am subsetting it on
Mm-hmm.
the basis of sixth vector or the sixth column, which is df dollar v6 equal to 6. So it will give me 3
Mm-hmm. 3. Okay.
because it will be false, false, true, and so
Right.
true is the third location, and we have the 3 as a value in the third location.
Got
Okay.
it. Yeah. So, for example, if we want to get the whole row of that, if it is true, right? So, how do we?
You want whole row when v6 is equal to 6.
Right.
Okay.
Oh, just a DF.
Yeah, that's it. Got it?
No, got it. Okay.
So it's little different. So let's understand this.
Yeah, yeah.
So what I have done, uh, I have passed this logical vector as in the row argument. Okay.
In the row. Oh, yeah. Hmm.
So step one is that I am typing df and then I am putting square brackets. Step two is
Yeah.
that what I finally want. I want the sixth row or the third row, whatever. So if I want
Hmm.
to
Okay.
filter it on the basis of rows, then obviously I have to do subsetting at the row argument only.
Oh, got it. Mm-hmm.
And I want all the columns. So after comma, I have left it blank. Now
Yeah.
in the row argument, let's see what all it has passed. So again, it is a logical vector.
Mm-hmm.
And
Yes. Yeah.
if I run this logical vector, then it is giving me false, false, true. So
Right.
my row argument has become false, false, true. And I know that
Yeah.
it will only pull the or consider the location
Third.
wherever the vector is showing me true values.
Yeah.
So in the row, it will only, in the row argument, it will only pull the value that is present in the third location.
Got it. Yeah.
So,
Yeah, I got it. Yeah.
okay. So it has, in a way, converted it into this thing, df 3,
3 comma.
comma,
Comma. Yeah.
right? So that's the final
Okay.
thing which it has done.
Okay.
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 Now let's look at one bigger data frame, and then subsetting, we will be good with subsetting part. So here, first let's understand this. What I'm doing is that I'm creating a data frame. Is this slide visible to you clearly?
Yeah, yeah, that's fine because it's not in the, yeah, now it's more clear, but yeah, I'm able to see that other version too.
Okay. So here,
Yeah.
first I'm creating a data frame with
Mm-hmm.
first column as school and second as class. Now in school, what I'm
Oh, okay.
doing, I'm using REP function. So REP is a function in R, and what it simply does, it is used to repeat certain sets of values, right? Very intuitive. So
Okay.
REP SPC, which is a character, comma 6. So it will repeat SPC 6 times.
Oh, okay. REP is for repeat.
Correct, correct.
Okay.
Then REP CRDS comma 6. So again it will repeat CRDS 6 times.
Okay.
And now my C thing is combining both these two things together. So my school has become a vector with top 6 values comprising SPC and next
Yeah.
6 values
The other
comprising
third.
CRDS. So its
Mm-hmm.
length is 12. Okay.
Okay.
So I used REP function. Otherwise, I would have typed SPC 6 times and CRDS 6 times. So in order
Yeah.
to avoid that, so this is my school vector.
Okay.
Now this is the second vector class. So here I am repeating values from 1 to 3, and each one I am repeating 4 times. So there is a function each, or you can say argument each within the REP function in R. So
Okay.
what it will do, it will repeat the values within this vector 1 colon 3 4 times, each value 4 times.
Yeah.
Okay.
Oh, okay.
So let's try this. Now if we'll run this data frame. Okay, so this is the one which we imagined and it is there. We have school, we
So
have
it
class.
repeated. Okay. Each value 4 times. Then it's not like,
Each value 4 times, yeah.
yeah.
So far so good.
Yeah. Yeah.
Now I'll be writing bunch of functions here. to get the different types of information. So if I want a data frame with second, only those rows where second column is 2.
Right.
Wherever second column, which is class, is having values as 2, I only want that data frame.
Right. Yeah.
Okay. So I have done subsetting here. So in the, look at the row part, row argument in this df1. So I have written df1 comma 2 equal to 2. So what it is doing?
Right. Row argument.
And the column argument I have left blank because I want all the columns.
Yes.
Now see, again, this is a logical vector. So this subsetting is all about, writing logical vectors. So
Okay.
I have run this row argument df1 comma 2 equal to 2. So this is the first argument. Okay, row argument.
Yep.
Now it is simply checking that wherever the class column is equal to 2, it will only so it is just checking. So it is giving me logical vector. So whether it is equal to 2 or not. So it has given me false, false, and true, true, blah, blah, blah. Now, when I will pass these 12 values of logical vector in the row
understood.
argument.
I mean, you don't have to. Yeah, I'm clear.
Okay.
I'm good.
Okay.
Yeah.
Now cbind, I've already shown you.
Right. You added the stuff. Yeah.
So we'll add here df1 comma age equal to 5. Now in this case, when I define variable, then we only write equal to sign once. Okay. Age equal to 5. So
Right.
here we don't write twice. This is just the naming of that particular column. But when we write double equal to signs, that means we are applying the condition.
Right.
Okay.
Yeah.
So I have created a data frame with age as a third column. Now, what I am here trying to do is I am applying multiple.
What happens?
Yeah.
Yeah.
So
what happens if we type age equals 1:5? Is it going to repeat after that, or it's going to come up with error?
No, it will be okay. So I have to write 1:6 or 1:12, right? Because it has to be which I showed you yesterday.
Multiple. Okay.
So if I do 1:6, then 1:6, it will be repeated.
Repeated, yes. Okay.
If I write 12, then it will be a unique set of values. Okay.
Yeah.
Now, what I am trying to do is through subsetting, I want a data frame where school equal to SPC and class equal to 2. So I want the complete data frame with all the columns wherever my school is SPC and class equal to 2. So we have this AND indicator here, AND functionality here.
There are two conditions, right?
Yeah, two conditions, and that too in the row argument. Column is blank.
Yeah.
Why it is blank? Because I want,
class is F1. I didn't get that. $sign class.
Yeah, take your time. Take your time. I'm here. Just look at this.
Yeah. I got the first one. We're combining we're checking the SPC value in the school column, right? So, that is a class column itself. Okay. Now we're checking the class column for 2. Okay, got it. I completely forgot we have a column called class. Okay.
Yeah. So we have
Got it.
three
Yeah,
columns:
I'm with you. Yeah.
school, class, and age. So age is the one which I
Okay.
added afterwards, and school and class were there
Right.
already there.
Yeah, I'm good. Yeah.
Okay. So as expected, school, it has given only 2 rows based on the logical vector that resulted from that multiple condition inside the row argument. Okay.
Right.
So this brings to an end of subsetting.
Okay.
Now,
Yeah, this is critical, right? It's very good.
yeah, it's very critical
Subsetting.
because you can do so many data manipulations just by writing subsetting different values.
Right. Yeah, makes sense.
And you can run dynamic for loops and also we will see that.
Okay.
So I am putting one file in Google Analytics.
Like data or something.
Data sets. Upload data sets. So just download this. So are you trying these functions along with me, or you are just following this thing?
So I'm following today because yeah, you're copying the stuff from the slides, right? So instead of typing, I'm just following.
Yeah, but that won't be true always because in the
I know.
because in
Yeah, definitely. Yeah, because the way you're doing, it's difficult to type the whole DF and then, yeah, because I don't have the slides to grab and then paste it. But yeah, sure. For definitely, I would like to, yeah, get this CSV and then, yeah, do the steps.
so just download this CSV file.
Yeah, got it. Sure. Mm. Yep, I got it.
Okay. So first, let me open that file right in the CSV format, and then we will
Okay.
import this. So this is a CSV file, and
Yeah.
so it contains columns like MPG, which is miles per gallon. So this is a
Okay.
auto industry data, automobile data basically,
Mm-hmm.
across
Yeah.
different cars, and MPG stands for miles per gallon. So what is the average or mileage of that particular car, and it is
Yeah.
a
Got it. Yes.
continuous
Sure.
variable. Okay, so it is continuous. It can
What
have,
is the third one?
so it is
Display the speed or
displacement, then horsepower, then weight.
yeah. What is displacement means?
So I'm also not very much. Uh,
Okay, that's fine.
we won't be
Yeah,
using this
just trying
column
to.
right now.
Okay, yeah. Draft weight.
Gear.
Okay.
This J column is AM, which means whether it is automatic or manual. So whether your car is
Ah,
automatic
okay.
or manual. So it is that
Right.
indicator. So we are importing this here.
Yeah, all automotive cars, they have all the diagnostics, so it could send all this information back to the manufacturer.
Yeah, yeah, yeah.
Yeah, got it.
So what we will be doing here, first let me give you an overview what we'll be trying to cover from this session, this particular slide, and then we will
Okay.
look at it one by one. So this would be a syntax read.csv, and
Mm-hmm.
that's a function in R, read.csv, okay, and it
Oh,
imports,
read.js is a function. Okay.
yeah, and
So
then
do we know, for example, how to search for these functions, and then all the like help,
yeah,
the
yeah.
these instructions, everything.
Yeah, let me show
Is
you.
that the double question mark inside the R? Or?
So so there are two ways of looking at this. One is simply
Yeah.
a question mark.
Question mark and then csv.read, or you just look for read?
So I have written read.csv function as a whole. So the difference between single question mark and two question marks is that if I don't
Yeah.
know the function exactly, then I type double question mark. And if I know it exactly, then I type, but I don't know, I mean, what is the exact functionality of that function, then I type single
Yeah.
question mark, because I know the function name, but I don't know exactly what all it can do. Okay, so
Yeah. What if I don't know the function name? For example, I wanted to know like how to read a XML file, XML data, right? So how do you type it? So guess like question mark read.xml, or is it?
yeah, so it's double question mark read.csv. So the one which I have done it just now. So double question mark, and let's say read file, for example. Let's see what it gives.
No, I'm looking for XML, right? So if I want to do that,
XML,
yeah,
read XML, right?
yeah,
Okay, so this R functionality is not giving this thing right here in the R Studio,
yeah.
but you can obviously,
Mm-hmm.
type that thing in Google. So
Okay. Or if we just type XML, does it give you anything?
read XML in R. Yeah, so here you can get a lot of help. So in double question mark, suppose if I type that regression thing,
Yeah,
then it gave me all that. So there is a help, in the right
yeah,
hand side. So first is
right.
the files, which gives the files, then plots. So I'll be drawing a lot of plots today. Then packages, then help.
Okay. That's fine. I'm kind of interested in reading like a JSON and XML data. So just trying to, yeah, I'll Google it and see if what I can come up with. So I have a sample of JSON data, so I want to read it.
So let me type JSON there. Maybe it is able to.
Maybe space, or is just read JSON. No. Dot.
It is saying no results found. So it has to be done through Google then.
Yeah. Okay, got it.
Yeah. And if I know exactly, like GLM is a function in R, then it is giving me. So GLM is a function in R, like generalized linear model. And since I know that it
Okay.
is a function in R, so in the
Yeah.
right hand side it has given me all the various arguments that can be passed through that.
Okay. Cool.
Okay.
Sorry for diverting. Let's go back.
Okay, so let's read this file. So what we'll be doing, yeah. So first let me give you the overview. So first we'll be
Yeah.
reading this file in R using read.csv functionality because this file was in CSV format. Then we will
Mm-hmm.
apply some data exploration functions, uh, class head and so on.
Mm-hmm.
Then it is continued, few more data exploration functions. So all are having sense in terms of logical flow. So we have to apply these things in order to understand this data. Then data summary functions, table, range, apply, mean, sum. Then we'll do conditional and looping. So conditional
Mm-hmm.
we will apply using if else, and there are two ways of looping. One is for loop and another is apply function, which I'll tell you how to do that. Then we will do the missing value identification and how to treat the missing value in all those columns which we have just seen. Okay.
Yeah.
So is.na is a function in R which checks the presence of missing value, and then we will see that how to treat missing values in case of continuous variables or numeric variables, and in the case of categorical or character variables.
Okay.
Then we will check the outliers in the data, how
Mm-hmm.
to detect them, treat them. So there is a box plot function in R, which is a
Mm-hmm.
very useful function in fact. So it's just a screenshot of one of the uh, when I applied box plot to one of the vectors or one of the columns. So as I told you that each and every column in a data frame can be considered a vector, right? Because it is a unidirectional, right? A vector or a
Yep.
column is always unidirectional. Okay. Then we will do uh, distribution analysis of the variables, and we'll be drawing histograms to understand the distribution, that whether it is normally distributed or Gaussian or whatever. So there are a lot of distributions.
Mm-hmm.
Then we will understand the transformation, because there are many times when the variable is not normally distributed and we want to see if we can transform that variable to normal distribution. So there are various techniques to do that, maybe logarithmic transformation or square root or a square. So this type of
Okay.
stuff we will see that which one is helping us to achieve the normal distribution. And why normal distribution? Because normal distribution is having lot of applications in statistics. Lots of algorithms and data analytical or statistical algorithms or modeling techniques have been built around normal distributions. So they assume that your data, underlying data, is following normal distribution. So it's very important to see if our data can be converted to normal distribution or not.
Okay.
Then we will check. So after this variable transformation for this particular data set which we have imported, so our exploratory data analysis will be over till this point. So
Yeah.
from this slide we will look at another data, uh,
Mm-hmm.
and we will analyze like uh, the similar set of things which I have just mentioned, whether it how missing values or outlier treatment and uh, box plot and histogram and transformations. So we'll be practicing that thing in another data set. So the data set which we have just imported contains only 32 rows. So it's a very fairly small data. So first
Yeah.
we will get the flavor of the smaller data set, and then this is the bigger data. So it will be a
Yeah.
checkpoint to differentiate between these two types of data sets. And we will do a lot of box plots. So these are 12 different box plots, and we'll see how to draw them and to how to understand them and how to uh, remove outliers. So box plot basically is used for uh, checking outliers, whether outliers are present in my data or not. And what are the outliers? Outliers are basically the too much maximum or too minimum values that is present in my data. So for
Yeah.
example, uh, we
I got it. I got it. Outliers. Fine.
yeah. So for example, in a class of eighth standard, so uh, all are having age of around, let's say, 12 or 13, and for example, due to data issue, an age of 50
Yeah.
has been put inside that. So we know that in
Yeah.
eighth standard, age of 50 is not possible. So that type
Mm-hmm.
of stuff can be captured using outlier treatment techniques in box plot.
Sure.
And then we will draw various histograms within this uh, bigger data set, and we are trying to see here that whether it is normally distributed or not. So as we can see here, it is not. So I'll tell you how to check that. And then
Mm-hmm.
normal distribution rules. There are some rules how to what is the percentage of data that lies within various segments of normal distribution probability density function. So I'll tell you what is probability density function, BDF.
Okay.
Similarly, how to plot, means and plus minus 2 standard deviations in histogram. So we have a functions to achieve that. Yeah, so this much.
Okay. Yeah.
Okay,
Interesting.
let's do it quickly. So I've read this
Yeah.
file.
If you could save this file also after the class, send it to me because we did more things than we have it in the slide.
Yeah. So here there will be a lot of differences because in slide I have only mentioned the concepts and coding is not there.
Yeah.
So
Yeah. Yeah, save that script file too.
okay. So I'm putting this file there, so you can follow it along with me.
Okay. Sure. No, so far you typed something, right? So can you save that as another script or the
No, I
one you
haven't
have
typed. Okay, so the one which I used for the subsetting, right?
subsetting? Yeah.
Okay. Okay, so both the files I have placed there. So just open this
Okay.
read from CSV file so that you can also practice this along with me.
Okay. Sure. So yeah, let me download it.
Yeah.
Okay. Open it.
You have downloaded it, right?
Yeah, I got it. Yes. Downloaded the file. Opened it in our studio.
Okay. So let's do the data exploration one by one. So
So
class.
first we need to read the file, right? So we need to change the path
Yeah. You have to write your own
for
local
me.
path.
Right. Yeah, just a second.
I'm just coming in a second.
Okay. Okay.
Yeah, I'm back.
Okay.
Okay.
I'm able to read the file.
Okay. So,
So when I did this Control R,
mhm.
yeah, it came back, and then does it show anything in the display, or I didn't see anything.
Yeah. So why you didn't see? Because that thing got stored in empty object. Okay. So now you have to execute the empty object also. So let me show you.
Mm-hmm.
Right? Because
Yeah,
you
yeah.
have assigned
Got
that thing
it.
to empty object.
Empty. Okay, got it.
Now if you will type empty then control R, then it will show you.
Okay.
Okay. Then
Yeah.
class of empty, it is a data frame. Now head of empty. So head gives the top 6 rows of the data frame.
Okay. So is
Then
there a way we can change the size of the windows? For example, if I wanted to have these bigger than others,
which one?
the R Studio has 4 sections, right?
Mm-hmm.
So can we change the section? Like I wanted to see the source and then the console have a bigger area than the other two. So can we move to the other side or no? We can just close it. Uh, no.
It should be possible. Let me check.
Yeah, it doesn't see a resize of each window.
Mm-hmm.
Yeah, I just want to move to the side so that I can have more the source and the console because we don't use the other sides that much. Or can we change it on? Okay, you can adjust here on the top and bottom on the same
Mm-hmm. Correct.
button or to the sides. Okay, that's fine. Kind of curious.
Yeah. So I'm also checking it if it is. So as of now it is not allowing, but I will look at it again afterwards so that
Okay.
if there
Sure.
is any setting, maybe in tools it is there. So I'll check it later. So
Okay.
head give me top 6 rows. Tail,
Header gives you just a second. Hang on. Yeah. So crab is that. Head is. I thought head is the. Say it again. Head is not the column names.
no, head is a function.
Yeah. Head of empty. That means what? What are we getting?
Top 6 rows of the data.
I'm sorry.
Top 6 rows of the data.
Top 6 rows. I don't get it. What do you mean top 6 rows of what?
So
Oh, first 6 rows.
yeah,
Okay,
first 6
got
rows, yeah.
it. Yeah. Okay.
Okay, and you can change this. If you type here empty comma 10, then you will get top 10 rows. So it is changeable.
Okay.
Then we have a tail. So head is used to check, whether I have received all the columns and all the data and to get the field,
Yeah.
because this is a very small data, only 32 rows, but you may have,
Right.
thousands of rows. So head will give you the, look and feel of the data, of the glimpse of the data.
Yeah.
Okay.
Okay.
Tail gives me the bottom 6 rows.
Mm-hmm. Yeah. For you, I mean, maybe because of the font size, everything is coming up in one row. For me, the crab, it is coming in as a different set because it's not fitting in
Oh, okay.
one row.
Okay. No
So
problem.
maybe, yeah,
That's
I
fine.
got it. I can adjust the size of this maybe in the default. Okay. Let's see if I can get everything in one row now. Okay. Yeah. And now it is showing up. Okay.
Okay. Then
Okay.
row names. So row names does not matter much, but it will simply, if you will execute that, so it will give the row numbers 1, 2, which it has, R has done it automatically. So that's not of any significance. You can ignore this. Then we have call
Okay.
names. So
Yeah.
call names gives the, column names of all the
Column.
columns.
Yeah.
Correct. Then when we have one more function str. So it's a very useful function. It gives the structure of all the columns in the data.
Hmm. Okay.
So we have factor as one of the data type, numeric, integer. So factor is basically character
Okay.
only, character or categorical. So wherever you will find factor, it means that that data is character data, because you can see that it is giving factor against the first column, which is the car names or car types, right? So let's look at
Which
the
one?
first.
So,
Okay.
say it again. The sector, is that?
Yeah, factor. So if you will see the first column $X, right?
Right.
So only this column is a factor column. Remaining are all the numeric or integers, right?
Oh, yeah. Okay. Okay. Mm-hmm.
So what I'm saying is that factor means character data.
What data?
Character or categorical.
Character, right. Okay.
Yeah.
Yeah. Okay. Okay. Yeah.
So if we want to
Sure.
see that first column, so let's see that what all it contains. So empty. So how you will do? Again, the game of subsetting only. So all the rows and
Yeah.
first column. Okay.
Yeah.
So here it is. So Mazda, Datsun, Hornet. So since all these are character
Sure.
values, right? These are non-numeric. So that's why
Right.
In my str portion, it is showing me as a factor variable.
str is showing character variable.
Yeah. So str gives the structure of the
Structure. Right.
columns.
All the columns. So it says one is the, yeah. So everything else is numeric or integers, right?
Yeah, except this column remaining are numeric.
Yeah.
Now there is a function nrow.
Okay.
So nrow gives the number of rows in the data. So we have 32, so it has given us 32. Then ncol,
Okay.
it gives the number of columns. So
Number of columns and columns. Okay.
there are 12 columns.
Subbase. Okay.
Now, if you will recall, different ways which I showed you how to call the column. So I showed you couple of 3 ways,
Then,
right? One is dollar,
yeah, name of the column.
name of the column, right? So empty dollar CYL. So CYL is basically cylinder. You can see,
Cylinders.
look
Yeah.
at my console. So here the third column from the top. So it says how many cylinders are there in your car. So I can call this as a empty dollar CYL. So let's run this. So these are the values. Some cars are having 6, some have 4 cylinders,
Yeah.
some have 8, and so on.
Right.
So, and let's also, get aligned with our PPT, like what is the inherent logic of telling you each and everything. So first we are focusing on data exploration functions, that once we have imported the data, then how we can explore this data in a way that what is a class, head. So that's why. So we are looking at all those type of things.
Yes.
Now, if I want to know which is in my cylinder column, so within cylinder column, what is the maximum value? Okay, so which dot max, right? So which dot max will give me the location, right?
Location. Yeah.
So it is saying me fifth location is the one which is having the maximum number of cylinders,
Right.
and it gives the first occurrence. So because 8 is not unique, 8 is present number of times, couple of times, but which dot max or which functionality always provide the first occurrence.
Yeah.
Then which dot min does the opposite. So it is saying me third location, which is 4, right?
Okay. To get the value, I just put that inside the empty, right?
Empty dollar
To
CYL.
find the.
So you have to do like this, empty dollar CYL, then you have to do the subsetting.
Okay. Okay. Got it. Okay.
Right?
Yes.
So in the subsetting, it is giving me fifth location in this command which I have typed.
Right.
And then what I'm saying, so empty dollar still is a vector, right? It is a vector. Empty dollar, empty is a data frame, empty dollar CYL is a vector. Now what I'm saying is that I want the location, or I want the maximum value of this vector. So for that, I have done the subsetting, and in subsetting, I want the location, right? So which dot max has given me the maximum location. So that's the way. Any confusion in this?
Okay. No. I'm good. I'm clear. Yeah.
Okay.
You can move on.
Now we look at some of the summary functions which I have shown you in the slide. So exploration is completed. So summary, let's look at some of the summary functions. So very simple sum function, and so sum function will give me, so I am doing sum function of the MPG vector or MPG column in the empty data frame, right? So empty $MPG. First let's look at what all it contains. Okay, so 32 values, and it is a continuous variable, so it is having 32 continuous or numeric variables values. Now if I want to sum this vector, so I have to write empty $MPG, because this is the vector I want to apply sum. So it has given me 642 or whatever is the sum. Then the range. So range gives me the min and max value. Okay, so 10.4 is the minimum and 33.9 is the maximum.
Okay.
Then simple averages, 20 is the average. Now there is a one very good function called table. It is a very useful function. So what it says, first of all, it is mainly used for categorical type of data. So CYL is numeric, but it is not continuous, right? Because it contains, so let me show you this. First let's see the values, what all it contains. So it is having non-decimal values, right? 6, 4, 8. So
Right.
so it is numeric, but it is not continuous. So there is a difference between numeric variable and continuous variable. Continuous variable contains all the values in an interval. So it contains all the decimal values, right? But
Oh yeah, got it. Yes.
but this CYL variable is not continuous, but it is numeric because it contains right, non-continuous values. So table function is very useful if you want to find the frequency of each value in a variable that is not continuous, okay, or that is categorical,
Okay.
or discrete. Yeah, discrete is a word for this type of variable.
Yeah.
CYL is a discrete variable, to be exact.
Okay.
So discrete variable means count variable. Okay, so my CYL is a discrete variable. So whenever you have a variable which is of discrete type, or you have a variable which is categorical in nature, like Mazda, car names, all that stuff, then table function basically gives you the frequency of each value within that particular variable. Okay, so let's do that.
Oh, cool. Okay.
So see this. So it is saying 11 occurrences of 4, 7 occurrences of 6, and 14 occurrences of 8.
Very good. Yeah, that's very useful.
And you can do one more thing which I forgot to write here. Prop.table, and write this table thing.
Okay.
Okay. So prop.table takes the table as a object. Okay. So first I have given table object within the prop.table function. So it gives me the percentage of 4, 6, and 8 within themselves. Okay.
Yeah.
So in this data, 34% cars has 4, number of cylinders as 4, and 44% has number of cylinders as 8, right?
Oh, it provides you the percentage.
Yeah, I am multiplying it by 100. So by default it gives in the form of proportions, but if you will multiply it 100, then it will give you percentages.
Okay. Proportion, and then you get percentage. Okay.
Right?
Right.
It's prop.table. Let me write it in your chat window. Send this function.
That's okay. I typed it. I got it already.
Oh, okay. Perfect. Now, there is the apply function. So I have written it in the slide also. So it is also used for summarizing the data in a sense that what I have done through sum. So this sum empty $MPG, it is giving me 642. The same thing can be done through apply. Okay.
Say it again. 642. What is 642? Oh, summary. I mean, that's sum, right?
Sum, yeah.
Yeah, yeah. Okay. You can use that in this. Okay.
So what apply function does, it applies the summary functions over a set of entire column if I pass the argument as 2. If you will see here, my second argument is 2. 2 means column wise.
Okay.
Or it can summarize row wise if I type here 1. Okay, so let's look
Yeah.
at this. So empty is my data. Now if I'll use apply function and I'll write 2 as a second argument, so it will give, and also notice the subsetting which I've done here. So empty row argument is blank, which means I want all the rows, but I only want fourth and fifth column.
Four and five or four?
4 colon 5. This means fourth and fifth both. So
4?
let's see it here. I'm writing it. 4 colon 5. So if I do this, empty row argument blank, comma 4 colon 5, then it will give me, and I do head of that. So let's use head here.
Okay.
Okay, so it is giving me second, fourth and fifth column.
Right. Mm-hmm.
So it is simple subsetting where in the data frame called empty, I am pulling all the rows. So that's why I left the row argument as blank, then comma, then column argument. So what I have written in the column argument, 4 colon 5. So 4 colon 5 means
Right.
fourth column and fifth column. So I could have written here in a form of C also if I wanted some separated columns. For example, 2 comma 6. So if I write this, then it will show me second, which is mpg, and sixth, which is some direct variable. So this is the way. Now apply function, as I told you, it summarizes the data in the form of rows or columns. So what I want my fourth and fifth column to be summarized in the form of summation.
Okay.
So fourth, which is
So what is that 2 indicate?
it indicates whether
2
you
means
want the
column
sum
wise.
column wise or you want the sum row wise.
Oh, yeah. I see. I got it. Okay. Okay.
So
if you want a total along the row, you can do that with 1. Okay.
Yeah.
Sure. Okay, makes sense.
So tell me one thing, that if you will use this function 1, where I've written 1 as a second argument, then what should be the number of values according to you if you use this number of values? Yeah.
Equal to number of rows.
Correct.
32.
Correct.
Yeah.
Absolutely. So we have 32 rows. That's why 32 values, because we are summing it for row wise.
Yeah.
We are summing it row wise, and that too only for fourth and fifth column. We are not summing it for all the rows, right?
Yes. Right.
Because we have applied the subset function, subsetting. We have done the subsetting, and we are saying that first only pull the fourth and fifth column from empty, and once you have done that, look at row wise and then apply the sum function. So that's the way to read it.
Right.
Okay. Now we want to create.
Actually, if we want, we can create another column, right, inside the empty, and then as a sum of fourth and fifth column.
So the way to do that is empty dollar. Let's say I'm writing sum1, sum1.
Yeah.
Not here. It has to be on the second second one.
empty equals, right?
Empty dollar sum
Yeah.
one, then assignment operator. Yeah. Okay. Now if I do head of empty, then look at the last column, sum one.
Oh yeah, yeah.
Now what we want to do is to create one column which contains 1 or 0. It will contain only two values, and 1 should correspond the cylinder value equal to 6 and 0 for the remaining. So this is the thing which we are trying to understand here. 1 for, so we want to create a new variable which will be having only two values, 0 and 1. Okay. Now the one
Say it
value,
again. We're
yeah.
creating a new variable.
So we want to create a new column which will contain
Okay.
only two values, either 0 or 1.
Oh, okay, okay.
And it will be 1 wherever the number of cylinders will be equal to 6.
Oh, okay. Yeah, yeah.
So we want to create this new variable. So let's see how to do this.
Okay.
So I'm creating a new data frame empty one, you know, so that my original data frame does not get disturbed.
Okay.
I can do in empty also,
So you
but
can,
to just keep a copy of, you know, so that my
yeah,
original end.
sure.
So we'll use if else function. Okay.
Yeah.
So the format of writing, so let me type this. So empty one, then dollar, then the column name of the new column. So it will be cyl underscore 6 because I only want, so it will be an indicator of number of cylinders equal to 6. So that's why I am naming it as cyl underscore 6.
Okay.
Assignment operator, if else is a R function, then empty one dollar $cyl. So this is my original cylinder variable, right? Empty one dollar $cyl.
Yeah, equals 6, right?
Equal to because we are comparing
Yeah,
it.
to
6.
compare.
So whenever it is 6, then I want 1, else I want 0.
Oh, okay.
So if I do head of empty one, then look at the top 6 rows of the last column. Okay.
Yeah, I'm also doing this. Okay.
Yeah.
Yeah. Got it.
Then table function I've already told you. Now let's do table of this new column. So since it contains only two distinct values, so it gives me frequency or count of that. So only 7 out of the 32 rows contains 6 cylinders and all the remaining are not equal to 6.
So there's 1. So that summary gives like 25. What is that? 7?
Table function, right?
Right. Yeah, it should give you a report, right? Summary.
The table function, output of table function is simply that value, and below that value is the frequency of that value.
frequency of the value. Okay. Right. Yeah. I see. Yeah, now I am reading it right. Okay. The top down.
Top
The
down.
zeros showed up, yeah. Zeros showed up 25 times and 1 showed up 7.
Correct.
So there are only 7 with cylinder 6 cylinder cars.
Yeah, in the entire data set. Yeah, correct.
Yeah. Okay.
Now, what we are trying to do, we want to sum all the continuous variables or numeric variables. So out of, so what is the number of columns? I think 12, right? And call.
Yeah.
13. So we know the first column is a character, but all the remaining 12 can be summed up because they are numeric. So we want to write a function so that we can apply the sum function for all the 12 remaining columns, and we get a vector that contains the sum of all the columns. So a vector that contains only 12 values, and each value represents the sum of the respective columns. So we want to do that.
Mm-hmm.
So there are a couple of ways of doing this. So one is a summary function. So this also is not written in the script file. You can note that.
Okay.
So summary is a useful function. It gives the variable wise report of that particular variable. What is its minimum, maximum? Yeah, but it is not giving the sum, right? Okay. So it is giving the minimum, median, mean, and maximum. It is not giving the sum. So let's do summation by some different method.
Mm-hmm.
You got it, right? So this one does not contain sum. If you do summary of empty, just do that.
Yeah.
Summary of empty.
Yeah, that's I'm looking at MPG. It has minimum, median, mean. First, what is that? First quarter or quadrant?
Quartile.
First what?
Quartile.
Quarter. Okay.
Tile. We have percentile, right? So quantile.
Quantile. I see. First quantile.
So first quantile means 25% mark. Median means 50% mark. Third quartile means 75th% mark.
I see. Okay. Okay.
Right?
Yeah.
But we wanted sum of all the columns. So this is not getting achieved by using summary function. So we have two ways of doing that. One, we'll be using for loop, and I'll tell you how to do that. And second is the using apply function. So let's look at them one by one. So in our writing for loop is fairly simple. Just for, and then within parentheses the minimum and maximum value of I in the form of vector 2 colon 13. So why 2? Because we want it from second column. So that's why I've written 2, and 13th is the last column.
Yeah.
And then you have to give the curly parenthesis after writing this, and then we are doing subsetting. So what I am telling are, so before that, let me tell you one more thing. Let's say we have a vector 1 2 3 4 5. Now what is the, so this is a vector A, okay, and it contains 5 values, 1 2 3 4 5. Now what is the way of adding the sixth value in it? How to add sixth value? Any idea?
How to add
sixth value. Sixth.
Sixth value.
Yeah.
So how to add sixth value? Or could you repeat the question?
So question is that my A vector contains
Yeah.
5 values, right? Now I want to
Yeah.
add, let's say, 2 more values in this A vector or 3 more values into this. So how to do that? I mean, how
Okay.
we can add more values to the existing vector?
C bind, right? That's one way
Cbind
to
is for
do it.
data frame. Cbind is for data frame, but I haven't told
Oh,
you for vector.
only.
So the way
Okay.
to
Okay.
do is simply subsetting. So what I'm saying is that A6 assignment operator, let's say 100.
Okay.
So that's the way. So if I'll type A and do Control R, okay. So it is giving me,
Okay. Cool.
okay. And other way around, I've already told you. Let's say if I want to read the third value of this vector, then again subsetting A of 3, right?
Yeah.
So subsetting can be used here both ways, either to insert the value or to pull the value.
Okay.
Now let's look at this for loop. So first I have defined it, the range of the columns which I want to traverse, because I want to
Yeah.
I want the summation of all the continuous or numeric columns. So 2 colon 13.
Yeah.
Then within curly parenthesis I am saying A and then subsetting I minus 1. So I
Yeah.
is 2 in the first case and I want the first value, right? So that's why I'm saying 2 minus 1. So it will, and A is the empty vector earlier. So let's say if I'm doing it as a B. So there is no B vector currently, correct? So if I type B here,
Yeah. We don't have
yeah,
anything.
object B not found.
Okay.
So I am creating a new, entirely new vector B and I am
Yeah.
using the subsetting functionality to insert value into it one by one.
Okay.
And I'm saying what it has to do in the first position of B vector, simply do the summation of empty one vector
Mhm.
with no row argument because I want the sum of all the rows, but for only the ith column, which is the second column.
Yeah.
So if I, let's say, simply do this thing, B and let's say first vector, yeah, so B is my vector and what is the first value of the B vector? This I am defining it, that put the sum of empty1, then again subsetting, I want all the rows, so I'm leaving it blank, comma,
Yeah.
I want, let's say, second column, I want the sum of second column,
Mm-hmm.
so 2
Yeah.
and that's it. Something I missed. Yeah, so what it is saying, B object not found, because I have to first initialize or initiate this B vector. So there is a way, simply write B and C and empty brackets, right? So that's
Yeah.
the way to initialize this. Yeah, now it has worked. Because earlier it didn't know that what is B. So I told that B is a
Okay.
vector. So C with
Yeah.
empty brackets means B is a vector. Well, wherever C comes, it means that it is a vector. Or colon comes, then also it is a vector. Okay.
So we are using without going through without using the for loop, the same thing. Well, trying to find the value.
So
But summing up.
for loop we'll use to get the sum of all the columns. But this I am showing you for how to do it for one column.
Okay. Okay.
Because I
Got
have
it.
hard coded it, right? I have written 2 here inside the columns. I have written 2. So I have hard
Yeah.
coded it. So this I am telling you
The
how
second
to.
column. Yeah.
So if I do,
So type B, and what do you have? Okay.
and
That
what
is
is,
the second column value, 642.
yeah,
Okay.
yeah, it is the sum of the second column. And what is my second column? Let me do the head of that. Head of empty1 subsetting 2. This is my, okay, it is not giving me the names, column name. So I am doing it head empty one. So second column is MPG. Okay.
Yeah.
So the one which I have highlighted here, what it is doing, it is summing the second column of this data frame and assigning that to the first value of the B vector,
Yeah.
or first location of the B vector. Now
Right.
I want to achieve this for all the 12 columns. Okay.
Yeah.
So that's why I've written a loop for I into 13,
Okay.
and I'm simply running this loop now. Now let's look at the B vector, and here it is. So B is a vector, and each value of that vector represents the sum of the columns in the data frame empty1.
Right. So if we wanted to add this as a row, right, at the bottom of the summary, all the rows, like we have 32 rows, we wanted to insert this as a 33 row as like a summing.
Yeah, so there is a function called
Then
rbind. So very good thing you have
R
asked.
bind. I see.
I forgot to mention it.
C bind, column bind, and R bind. Okay, got it.
Correct. So let's do this. Let's try this. So my empty1. So what I'm saying is that in empty1, do the rbind of again empty1, comma uh, B, but it will give an error currently. Let's look at this. Yeah, because if you remember that there are 13 columns,
Yes,
right?
yes,
And it contains
yes.
only 12.
Okay. But in your, okay, right, right. Mm.
So let's do one thing. It's fairly simple. So I'm doing it like this. B of 1. Let's say I'm putting it my name. Okay, so I have hard coded the first value.
Yeah,
So now it contains 13, right? It contains 13, correct. So now it will
no,
do the rbind. Where that function has gone. Yeah, here it is. What it is saying, empty1.
are you able to get it? For me, I'm getting invalid.
Yeah, it is giving invalid because you know what is the problem? The problem is
Mm.
that a vector can be either numeric or character. But here I am trying to mess it here, right? I am because uh, here what I'm trying to do is that within a single vector, I am putting character values also and numeric values also,
Right. Okay. Yeah.
right? And a row can never be a so in this case a row contains both these values, character and numeric. So that's why
Yeah.
it is, you know, throwing up an error. So that's the reason.
Yeah.
Let's try it. invalid type character.
So what if we just type some number 0, then give you that?
Some character of argument.
What? Character level.
It's giving error MT1. Why it is giving error? D I minus 1. What is MT1? Add of MT1.
So you calculate everything.
Into 30. Error in some invalid type character of argument. So let me look at it afterwards. Something is going on.
Yeah, that's fine. Sure.
Okay. So one is this for loop and second is the apply function we can use to get the summary of columns. Okay.
Yeah.
Oh, something is going wrong. Yeah. So now it is working. Okay. Okay. So instead of MT1, I'm using MT because in MT1 there is some messing which I've done, which I'm unable to figure it out right now. So I'm using the original data frame MT. Okay. Now in the original data frame, we know that there were 13 columns. So
yeah.
So simply I'm using the apply function and I'm pulling the all the columns except the first column. Okay. So 2 colon 13 and
Yeah.
so 2 and the second argument is 2 which says column wise, right? And then we have the sum. So it is giving me the sum of all the columns. And this is the thing which we were trying to achieve, right? The column wise sums. So one was the using the for loop and second was using the apply function. Similarly, you can type the function as range. So now you have the ranges of all the columns. You can have means for all the columns.
Okay.
No, again empty. Control R. Yeah. You got this apply function, right? So I am writing different functions, sum, range, and mean. So the beauty of this apply function is that I am getting rid of that for loop. So without using for loop, I am able to get the traversing across all the columns in the data set.
Yep.
Because I'm using 2 as the argument, second argument, right?
Yeah.
So this means column wise sum and one means row wise sum. So this we saw earlier also, I remember when we were in the initial part of this file. So there also we use apply function. So it is basically the same.
Yeah.
So there, yeah, we were doing it for fourth and fifth column, 4:5, I remember. Here.
Yeah, sure, yeah.
So now here we are applying it for all the columns. Yeah, correct.
Right. Okay.
Okay, so we'll continue this thing, missing value and all that remaining stuff.
Yeah.
We can do that next week, and a couple of other things we'll include. Yeah.
Okay. Yeah.
I think
Cool.
that's it for today's session.
Cool. Thanks, Puneet. Appreciate it. I guess we'll continue next Saturday then.
Yeah, sure. Same time, right?
Okay. Yeah. So yeah, just I'll go through the slides and then go through these samples again one more time. And yeah, if you could look at the stuff how we can read the JSON and XML, that would be helpful for me.
Yeah, I will work on that. Yeah, in the next class I will show.
Okay.
And meanwhile, if possible, just send me the sample of the JSON file over email, and I will develop a query to cater to that request.
Okay. Yeah, I'll try to send it.
A small sample of 10-20 records, whatever is convenient to you, and then we will do that.
Yeah, sure.
Okay. Perfect.
Cool.
Thanks for your time. Have a good day.
Yeah.
Bye. Bye.
Thank you too. Bye-bye.
Okay. Bye.
Bye.